Hi guys, welcome to my YouTube channel. In this video, we learn about compound interest. Compound interest is the interest earned on both the original principal and the interest accumulated over previous investment periods. So here, the interest obtained is going to earn you another interest, right? Since compound interest earn interest on interest, the money obtained in a compound interest investment is much higher than that of a simple interest investment. How do we compute the accumulated amounts in a compound interest investment? So to compute the accumulated amounts, we use the following formula. We have A is equal to P into brackets 1 plus R on N brackets close exponent N times T, where N is the final amount, that's the amounts obtained after the investment period, and P is the original amount invested in the account, and R is the interest rate expressed as a decimal, and N is the number of times interest is compounded per year, and T is the total time in years, that's the total time of the investment. How do we compute N? So N is called the compounding frequency, right? So the value of N depends on how frequently the interest is compounded per year. So if the interest is compounded annually, that's once per year, then n is equal to 1. And if the interest is compounded semi-annually, that's 2 times in a year, then n is 2. If the interest is compounded quarterly, that's 4 times in a year, so n is 4. And monthly, so we have 12 months in a year, and so n is going to be 12. And if the interest is compounded weekly, that's n is 52 because we have 52 weeks in a year. And if the interest is compounded daily, n is going to be 365 because we have 365 days in a year. Now let's start solving some questions. Question 1. An amount of 30,000 US dollars is deposited in a bank account that pays 6% interest compounded annually. What will be the maturity value of the investment after 4 years? Solution. The first step is to start identifying the values. We are being told that an amount of 30,000 US dollars is deposited in a bank account, right? So here the initial amount, that's the principal, is equal to 30,000 US dollars, right? And the interest rate, as we are being told, is 6%. So we have R equal to 6%, which is equal to 0.06. And we are being told that the interest is compounded annually. So that's the compounding frequency is equal to 1, right? So we have N equal to 1. Now let's find T. So T is the total time in years of the investment. So here we are being told to find the maturity value of the investment after 4 years. So here T is equal to 4 years. So we have all the values we need to compute the maturity value. So from the formula, A is giving us P into brackets 1 plus R divided by N, all exponents N times T, right? We are going to have P, which is giving us 30,000, multiplying 1 plus R, which is 0.06, divided by N, which is equal to 1, all exponents n times t. So n is 1 and t is 4. So this will be 4, right? So now let's simplify this guy. So we are going to have 30,000 into brackets 1 plus 0.06, all exponents 4. And this is equal to 30,000 into brackets 1.06, all exponents 4. So if you punch this on your calculator, you are going to have 37,874.3088 US dollars. So this is the maturity value of the investment after 4 years. Question 2. An amount of 30,000 US dollars is deposited in a bank account that pays 6% interest compounded semi-annually. What will be the maturity value of the investment after 4 years? Solution. The first step is to identify the key parameters in the question. So here we have an amount of 30,000 US dollars, and the interest is 6% compounded semi-annually, and the time is 4 years, right? So we are going to have P to be equal to 30,000 US dollars and R to be equal to 6%, which is equal to 0.06, and N, that's the compounding frequency, is equal to 2, because we are going to that is compounded semi-annually, so that's twice in a year. So N is equal to 2 and T is equal to 4, right? So the maturity value will be giving us A is equal to P into brackets 1 plus R on N, all exponents N times T. So here we have P giving us 30,000 US dollars, then 1 plus R, which is 0.06 divided by N, which is 2 in this case, all exponents N times T. So we have 2 multiplying 4. So let's simplify this guy here. So you're going to have 30,000, then 1 plus 0.06 divided by 2 is 0.03. 2 times 4 is 8. So we are going to have 30,000 into brackets 1.03, all exponents 8. So when you punch this on your calculator, you are going to have 38,003.1024. So this will be the accumulated amount after 4 years. Let's move on to our third question. With our third question, we have find the interest obtained on 10,000 US dollars at an annual interest rate of 12%, compounded monthly for 10 months. Solution. Let's identify the important parameters in the question. So here we have an amount of 10,000 US dollars, and the interest rate is 12%, and is compounded monthly, and the time period is 10 months. So here we have P to be equal to 10,000 US dollars, and R is giving us 12%, which is equal to 0.12, and N is giving us 12, right? Because the interest is compounded monthly and there are 12 months in a year, and the time period T is 10 months, right? But the time period must be in years, so we have to convert the months into years. So we have to divide by 12, right? And so T will be giving us 10 divided by 12. But here we should know that we are being asked to find the interest, not the entire amount at the end of the investment. And that is after computing the entire accumulated amount, we have to subtract the initial value from the accumulated amount to get our interest. So now let's compute the accumulated amount. So we have A giving us P into brackets 1 plus R on N, all exponents N times T. So we have 10,000. R is 0.12 divided by N, which is 12. All exponents N is 12 times T, which is 10 on 12. This guy will cancel out this guy. So we are going to have 10,000 into brackets 1 plus 0.12 divided by 12, all exponent 10. Let's simplify this expression. So we are going to have 10,000 multiplying 1 plus 0.12 divided by 12 will be giving us 0.01, all exponent 10. So thus we have 10,000 multiplying 1.01, all exponent 10. And this is equal to $11,046.22. From the question, we are being asked to compute the interest. So to find the interest, we use the formula A minus P, where A is the accumulated amount and P is the amount invested. So we are going to have 11,046 0.22 minus P, which is giving us 10,000. We are going to have the interest giving us 1,046.22 US dollars. Question number 4. If you invest 10,000 US dollars today at an annual interest rate of 8%, compounded annually, how long will it take for your investment to double in value? Solution. Let's identify the important parameters in the question. From the question, we have P giving us 10,000 US dollars and the annual interest rate is giving us 8%. So R is equal to 8% and the interest is compounded annually. So that's once in a year. So N is equal to 1. And then T is unknown because you're being asked to find the time it will take for the investment to double in value, right? So you're being asked to find the time the investment will double in value. So A is equal to 2 times P, right? So we have A giving us 2 times P, which will be 20,000 US dollars, right? Because P is 10,000. Let's solve for T. So we have the formula A is equal to P 1 plus R on N, all exponents N times T. So let's substitute in these values. So A is 20,000. So you're going to have 20,000 is equal to P, which is 10,000, into brackets 1 plus R, which is 0.08, because 8% is 0.08, divided by N, which is 1, then exponent 1 times T. So that will be T, right? So let's simplify this guy here. So you're going to have 20,000 is equal to 10,000, then 1 plus 0.08 times T. So let's simplify this expression. So we are going to divide both sides by 10,000. So we are going to have 20,000 divided by 10,000 is equal to 10,000 divided by 10,000, all multiplying 1.08 exponent t. So here we are going to have this guy to be 2 and this will go to 1. So we have 2 is equal to 1.08 exponent t. Our next step is to take natural log on both sides. So we have log of 2 is equal to log of 1.08 exponent t. So the t will move in front. So you're going to have log of 2 is equal to t log of 1.08. Thus t is equal to log of 2 divided by log of 1.08. And so we have t to be equal to 9.0065, so which is approximately 9 years. Thus, it will take 9 years for the amount to double in value. Thank you for watching. See you guys in the next video.